Hello and Assalamualaikum everyone. So for today's lecture, we are going to cover topic 5 on fuzzy rules. First thing first, let us take a look at the learning outcome. First, we are going to understand the rule structure, the fuzzy rule structure. The second one is to construct the rules using rules construction. Then we are going to interpret these fuzzy rules. Last but not least, we are going to take a look at the application of fuzzy rules on selected domain. First thing first, let us compare the differences between classical and fuzzy rule. So if you take a look at the classical rules here, okay. So you have two rules, okay, rule 1 and rule 2. So in classical rule, okay, if speed is more than 100, then the stopping distance is long. So if you take a look at this is actually distinct. Okay, it is not in fuzzy or ambiguous, right? The second one is rule 2, if speed is less than 40, so this one is distinct as well. Okay, then stopping distance is short. So this could be a fuzzy value. Okay, so if you take a look at the fuzzy rules here, if speed is fast, so this is actually our fuzzy values. Then the stopping distance is long. Rule number 2, if speed is slow, okay, another fuzzy value, okay, then stopping distance is short. So in here, okay, the linguistic variable speed has the range. For example, the universe of discourse between 0 to 220 kilometer per hour. But then when we talk about fuzzy set, this range will be defined as slow, medium, and also fast. Same goes to the linguistic variable for stopping distance. It can be between 0 and 300. So what we can do is we fuzzify to fuzzy set, and then the range of stopping distance can be short, medium, and long. So these fuzzy rules will relate to our fuzzy set later on. Yeah, we will take a look at that. So in fuzzy rule, actually fuzzy rule can be defined as a conditional statement in this form, if then form. So if x is A, then y is B. Okay, so actually x here represent what? Can you take a look at x here? Okay, x here are linguistic variable. So this is linguistic variable. Meanwhile, okay, A and B here represent linguistic values or fuzzy values. And these linguistic values is determined by fuzzy set on our universe of discourse x and y respectively. So x and y here is representing the linguistic variable here. Please don't get confused with x and y axis, yeah? Okay. So for example, if I say that if x is temperature, what do you think the linguistic value can be? Okay, A can be cold, medium, or hot, right? Okay, then I say that y is equal to time. Okay, time to recover, for example. Okay, if y is time to recover, so what would be B be? Okay, B can be short and also long. Okay, so what we can deduce from this fuzzy rule, if we have these two variables here, temperature and time to recover. For example, I say that if, okay, if I take example of cold here, if temperature is cold, then time to recover would be is long, for example. Okay, so I hope you can understand the concept here, that is, this is linguistic variable while this is linguistic values. Next, we can say that fuzzy rules relate the fuzzy set. Okay, in classical rule-based system, if the rule antecedent is true, then the consequences is also true. Why? Because we have those distinct value, that is 0 or 1 value, right? In fuzzy system, all rules fire to some extent, or in other words, they fire partially. So if the antecedent is true to some degree of membership, then the consequence is true to that same degree. So that is why we have the degree of membership here. So the range here from 0 to 1, for example, we have that 0.7 of degree of membership. So that is why it said that it fires partially based on our rule. Okay. So this fuzzy set provide the basis for weight estimation model. Okay. So we want to see the weight based on the weight estimation based on the tall, the height and the weight as well. Okay. So weight is actually the output. So height is the input here. Okay. So the model is based on the relationship between a man's height and his weight. So we want to deduce the weight, or we want to estimate the weight based on the height. So this is the rule that we can construct. If height is tall, then weight is heavy. So this is the input, while this is the output. Still remember, this is our fuzzy variable, this is our fuzzy values. So the values of the output or truth membership grade of rule consequence can be estimated directly from corresponding truth membership grade in antecedent. So this form of inferences use a method called monotonic selection. So if you take a look at here, okay, for example, the degree of membership in tall is say 0.3, okay, so we will plot this to our output, and we are going to have the value of weight based on the degree of membership of our antecedent. Okay, this one will be discussed later on the next chapter, so don't worry about this one first. Okay,